Welcome to the Deep Dive, brought to you by AI Opportune. If you want to really understand how artificial intelligence is actually rewriting the rules of business and tech, like without all the endless hype cycles, you really need to check them out. I highly encourage you to subscribe to AI Opportune for insights that just cut straight to the core of what's changing our world. So, yeah, let's unpack this today. I want you to just think back maybe a few years to those early viral deepfake videos.
Oh, yeah. The really bad ones.
Right. You probably remember them. You'd see like a celebrity's face mapped onto someone else's body, and the jawline is just glitching out completely. The skin tone is shifting wildly. And the audio, the audio sounded like a compressed MP3 from like 2004.
Yeah, it was super obvious.
Exactly. And we all laughed because the manipulation was just so obvious.
Yeah.
But today, nobody is laughing. Generative AI has evolved with such terrifying speed that human identity itself, just proving who you are, has become the primary threat vector in the enterprise tech world.
It is a complete paradigm shift. Because for decades, right, cybersecurity was always about defending the perimeter. It was keeping the bad guys from guessing a password or, breaching a firewall.
Right, the traditional stuff.
Exactly. But we aren't talking about credential theft anymore. We are talking about a fundamental crisis in how we actually prove we are biologically real in a digital environment.
And that is exactly what we are tackling in today's deep dive into the source material. We're looking at this whole new cybersecurity battlefield, specifically how modern enterprises are deploying AI to detect AI. So we're going to examine the invisible verification software that's protecting high-stakes workflows, the actual mechanics of how these systems distinguish a human from a synthetic clone, and, well, the roadmap for maintaining trust when our own eyes and ears are completely failing us.
Yeah, and to really grasp the solution here, we first have to look at how incredibly sophisticated the problem has become. We are miles away from the old days of poorly translated phishing emails,
Oh, yeah. The prince needs your money emails.
Right, exactly. The sheer velocity of the evolution is really what catches most organizations off guard right now. Because traditional security awareness training, it always taught you to look for typos, right? To verify the sender's domain, to check the URL.
Classic red flags.
Yeah, but generative AI just bypassed all of that basically overnight. Threat actors are now deploying these hyper-realistic, real-time impersonations that just render standard awareness training virtually useless.
Yeah, and there is no better illustration of this than the Erupt incident from early 2024.
Yeah.
For those listening who aren't familiar, Erupt is this massive multinational engineering firm. And an employee there was invited to what looked like a routine financial video call.
Just a normal day at work.
Exactly. So they logged in and they saw their colleagues on screen, including the company's chief financial officer. The employee recognized their faces, they heard their familiar voices, and because of that, they subsequently authorized a $25 million payout to what they thought were legitimate vendors.
$25 million? It's just staggering.
$25 million. But the twist is, every single person on that screen, the CFO, the colleagues, everyone was an AI-generated deepfake.
Which, fundamentally rewrites the rules of engagement. Because think about what didn't happen in that RUP case. The corporate network was not breached at all.
Right.
The firewall held up perfectly. No one, ran a brute force algorithm to crack complex passwords or anything like that.
Right. They didn't hack a system at all. They hacked human trust. But I guess from a purely technical standpoint, how is an attacker pulling off a live multi-person video clone? Because this isn't just like uploading a pre-recorded MP4 file. This was an actual interactive conversation.
Yeah, and that's the scary part. It involves real-time face-swapping software, and they combine that with generative voice models, and then it's all routed through virtual camera drivers. So the attackers essentially intercept the video feed, process it through a local machine learning model, which maps the target's face onto the attacker's actual physical movements, and then they just pipe that manipulated feed straight into Zoom or Teams or whatever.
Right.
Yeah, they are basically digitally puppeteering the executives in real time.
And obtaining the raw material to build those puppets is just trivial now, right? Like, an attacker doesn't need to hack into a database to steal your biometric profile anymore.
No, not at all.
If you are an executive or honestly anyone with a footprint, you have public conference presentations, podcast interviews, quarterly earnings calls. And from what the sources say, an attacker needs maybe 3 to 5 seconds of that clean audio to feed into a text-to-speech model and perfectly clone your voice for a business email compromise attack.
It's that fast. 3 seconds.
That's insane.
Yeah.
And we're also seeing reports in the sources of attackers using synthetic faces to pass live remote engineering interviews. Like, they get hired, They get shipped their hardware token, and they immediately start exfiltrating proprietary code.
Which brings us right to the core realization here, which is that identity is the new frontline. And I mean, it begs a rather urgent question. If the network wasn't breached in these scenarios, why are legacy, multi-million-dollar security stacks completely failing to stop the bleeding?
Yeah, because we all deal with so much enterprise friction daily, right?
Yeah.
The MFA prompts, the VPNs, the physical hardware keys. Why didn't any of that catch a 25 million fraudulent wire transfer?
Well, it's because legacy security controls are entirely focused on access validation. They are exceptionally good at checking if a set of credentials matches a database. But what they are fundamentally blind to is whether the entity holding those credentials is an actual biological human being.
Okay, so relying on an SMS code or an authenticator app right now, it's kind of like imagine a bouncer at an exclusive club,
Right.
right? And their only job is to check the VIP pass.
Right.
So someone walks up, hands over a perfectly valid, Golden Boss pass. The bouncer nods, checks it, and opens the door.
Yeah.
But the bouncer is just completely oblivious to the fact that a plastic mannequin wearing a synthetic rubber mask is holding the pass.
That is the exact vulnerability. That's a great way to put it. Because if an attacker intercepts your MFA code while they're running a deepfake video mask on a call, the traditional security architecture just logs that session as absolutely safe because the system is verifying the math, right? Not the biology.
Wow, okay.
And recognizing this massive gap has really forced the industry to pivot toward a new concept, which is known as enterprise authenticity.
Okay, enterprise authenticity. So we know human perception is obviously failing here. The AirUp employee genuinely believed they were looking at their CFO. If our own biological senses can't detect the fraud, how does a software platform actually do it?
Well, by fighting AI with AI, you basically have to remove human perception from the equation entirely because generative models have already surpassed our sensory thresholds. We just can't see it anymore.
Right.
So instead, enterprise detection platforms are trained to hunt for microscopic digital artifacts. These are essentially the structural footprints that generative engines inevitably leave behind when they synthesize media from scratch.
So it's basically digital forensics.
Exactly.
Let's break down the mechanics of how this actually works, starting with the visual side.
Yeah.
If I'm looking at a deep fake on a webcam, what exactly is the AI detection engine seeing that I'm missing?
So the engine is looking for things that an AI model struggles to render physically in real time. Take the physics of light, for example.
Okay.
There's this thing called subsurface scattering, which is how light penetrates human skin, scatters beneath the surface, and then reflects back. That is intensely complex computationally. So an AI detection model will actually look at the specular highlights in a person's eyes and calculate if that reflection actually matches the ambient lighting of the room they claim to be sitting in.
Wait, seriously, so the AI might perfectly render the CFO's jawline, but the light that's reflecting their pupil belongs to a completely different 3D environment?
Exactly. Because the generative model is essentially just painting 2D pixels, right?
Right.
It doesn't actually understand 3D space. It also looks for unnatural microexpressions because human faces have dozens of these tiny muscles that fire in highly coordinated sequences.
Yeah, that makes sense.
And deepfake models often get the timing of those twitches wrong. They also look for fringe jitter or like blurring where hair meets the background.
Yeah.
Those are areas where the generative model has to constantly guess the boundary.
Okay, but what if the attackers know the video is risky and they just, I don't know, turn the camera off? Because a massive portion of these social engineering attacks are purely voice-based over the phone. How do you analyze biological reality through just an audio stream?
It's a great question. Voice is actually incredibly difficult to spoof at a microscopic level because speech is a deeply physical process. Generative voice models, they don't have lungs, right?
Yeah.
They don't have a diaphragm or vocal cords.
Right.
They are essentially just high-speed prediction engines that are guessing the next acoustic frequency.
Wait, but if I feed a voice model, say an hour of my podcast audio, can you hear me breathing? Won't it just replicate the sound of a breath?
It will definitely mimic the sound of a breath, yeah. But it won't sync the acoustic latency with the physical exertion required to produce the subsequent words.
Oh, wow.
Yeah, acoustic models measure spectral biometrics. So they are hunting for missing natural breath pauses before plosive consonants, irregular cadence, and these subtle frequency glitches that are unique to the text-to-speech rendering engines. The AI basically forgets to pause for physical error because, Well, it doesn't need air.
That is fascinating. That makes a lot of sense. The system is essentially looking for the absence of biology.
Exactly.
Now, the sources also highlight something called behavioral biometrics, which seems to go beyond just looking at the media itself.
Right, because if you are operating a deepfake interface, you aren't behaving naturally on your computer. Behavioral analysis tracks live micromovements during a session. So it measures your natural eye blinking rate, your head rotation depth. It even analyzes the telemetry of how you interact with the machine, like your typing cadence or your cursor interaction patterns.
So basically how you're using the mouse and keyboard.
Yes. An attacker who is managing a face-swapping software dashboard interacts with their device very, very differently than an employee who is simply having a normal conversation on Zoom.
So we have the visual light physics, the acoustic spectral analysis, and the behavioral telemetry. But what happens when you combine all of them? Because one thing that really stood out in the research is this concept of multimodal signal fusion. If I'm understanding this correctly, it's almost like watching a badly dubbed movie, but on a microscopic network level.
That's actually a great way to think about it. Multimodal signal fusion is really the apex of this technology right now. It cross-references reality across the visual data, the audio stream, and the network metadata all simultaneously.
Okay, so it's checking everything at once.
Exactly. You might have an attacker with a world-class video deepfake that actually passes the visual check. But if the audio packets hit the server even a fraction of a millisecond out of sync with the video frames, the fusion engine catches it immediately.
And it checks the hardware too, right?
Yeah. Yes, the metadata. The metadata might reveal that the feed is being routed through a virtual camera driver, like OBS, rather than an actual physical webcam driver from Logitech or Apple or whatever. By fusing all of these data points together, the system dramatically reduces the chance of an attacker successfully spoofing their way through.
Which, I mean, all sounds incredibly robust, but it brings up a massive practical issue in my mind. Running real-time spectral analysis and multimodal signal fusion on every single video frame and audio packet that sounds like it would require just astronomical computing power.
Yeah.
Are we expecting companies to route every morning Zoom huddle through a massive server farm? The latency on that would be brutal.
Oh, absolutely. That's the main challenge. And it's exactly why enterprise security teams aren't building these fusion engines from scratch internally. They are relying on an invisible pipeline facilitated by established verification platforms.
So they outsource it.
Basically. The heavy lifting is done via API integration at the edge, which means they are extracting mathematical features rather than processing raw, heavy video files locally.
And we definitely see a lot of specialization happening here in the market. Reality Defender is a major player scanning live executive meetings for those multimodal artifacts. But what about sectors that rely heavily on legacy phone infrastructure, like banking?
Yeah, for banking and call centers, you see platforms like Pindrop, which specialize purely in voice biometrics and acoustic anomalies. They just sit quietly in the background of the telephony infrastructure.
Okay, and what if the interaction isn't live at all? Say I'm submitting a photo of a damaged car for an insurance claim to State Farm, right? An attacker could easily generate an image of a wrecked car using Midjourney to commit fraud. How does a company verify media after the fact?
Now, that requires a completely different mechanism, and that's handled by vendors like Trupic. Because instead of trying to forensically scan an image hours after it was taken, Trupic secures the media at the point of capture.
Oh, interesting.
Yeah, the software integrates directly with the mobile device's camera hardware, and the moment you snap the photo, it cryptographically seals the metadata, so the location, the time, the lens properties. If the image is generated by an AI or even just altered in Photoshop later, that cryptographic seal is broken.
Wow, so it essentially watermarks reality at the source. Okay, let's try to make this invisible pipeline really concrete for the listener. Imagine you work at a regional commercial bank. The phone rings, and the caller ID shows a major corporate client. They say they urgently need to move $100,000 to a new vendor account to close a time-sensitive deal. In the past, if the voice matched and they knew the account number, you probably just processed it. How does this new workflow operate?
So now the moment that call connects, the live audio is automatically routed through a background detection API. The employee taking the call doesn't have to press a button. It is entirely frictionless. The data ingestion layer extracts the audio packets, and the AI analysis engine just takes over.
And the speed of this is what's really remarkable.
Yeah.
Because the sources note it takes about 200 milliseconds.
Yeah, literally faster than a human blink. In that 200 milliseconds, the engine scans the caller's voice against baseline acoustic profiles and hunts for those synthetic generation artifacts we talked about. It's looking for those missing breaths and spectral glitches, and then it immediately generates a dynamic risk score.
But wait, scanning biometric vocal data on every single call raises massive privacy flags, right? Are these banks just continuously recording and storing everyone's raw biometric voice prints?
No, and it's a really vital distinction to make here. The modern systems aren't storing raw audio files of your voice. They extract a mathematical representation of the acoustic density, they compare it against the baseline or the synthetic models, and then they immediately discard the raw data.
Okay, got it.
It's essentially just a cryptographic hash of your vocal cords.
Okay, yeah, that makes it much more palatable from a compliance standpoint for sure. Now, what happens when that system flags the audio? Let's say the AI detects a spectral anomaly. Does it just immediately sever the connection and lock the client's account? Because, I mean, if a VIP client just has a bad head cold, or maybe is calling from a terrible connection at an airport, the AI might misinterpret that acoustic skew, right?
Exactly. And this is where the deployment strategy is critical. You never let the AI make the final firing or blocking call autonomously. If you let an automated system just drop the hammer every single time it detects an anomaly, you will completely paralyze your own business with false positives. The goal is security, not disruption.
Right. So how do you handle a high-risk score then?
Through very clear, predefined escalation pathways. If the score is low risk, the transaction gets an instant automated approval. But if the engine flags the 200 millisecond scan as highly likely to be synthetic, it triggers a human escalation. The call is quietly routed to a human fraud investigator.
Okay, so the investigator sees the red flag on their dashboard, and they take over the verification. So I might say something like, "Sir, for a transfer of this size, I need to send a push notification to your physical hardware token. Please tap the button on your device."
Precisely. That is called out-of-band authentication. You are deliberately moving the verification process to a completely separate, secure channel that the AI voice clone, which is trapped on the telephony network, simply cannot access or manipulate.
Which brings us to the operational roadmap. Moving an entire organization toward this concept of zero-trust identity verification. It honestly feels like trying to rebuild an airplane while it's in flight. How does an enterprise pragmatically roll this out without just bringing daily work to a grinding halt?
You start by mapping your high-risk workflows. You do not need deepfake detection algorithms scanning the company fantasy football chat.
Right, yeah.
You look for the paths that lead to the crown jewels. You identify processes that rely solely on facial or voice authorization, large wire transfers, granting executive system access, or, IT help desk password resets.
And once you know those critical paths, you integrate the APIs directly into the tools your teams are already using: Zoom, Microsoft Teams, Okta. You don't force employees to use some separate, clunky security application.
Right. The security has to live invisibly where the work actually happens. But, the final step of the roadmap is arguably the most difficult part because it really has nothing to do with software. It requires a profound cultural shift within the company.
Oh, absolutely. Because you can have the best multimodal fusion engine in the world, but if the employee is too terrified of getting fired to question their boss, the technology is completely useless.
Exactly. You have to run continuous simulation drills so that employees inherently recognize what a voice cloning attack actually feels like in practice. But more importantly, leadership has to cultivate a culture where an entry-level finance clerk feels completely empowered to challenge the identity of the CEO.
Yeah, if the CEO calls and aggressively demands a wire transfer, that clerk needs to know they will be rewarded, not punished, for saying, "I'm hanging up and calling you back on your registered device."
Right. If the executive team does not actively support that level of zero trust culturally, the technical safeguards will always eventually be bypassed by human error.
So bringing all of this together, the landscape is just irrevocably shifted. Securing an enterprise is no longer just about patching software vulnerabilities and monitoring network traffic. It is fundamentally about verifying reality itself. We have really entered the era of zero-trust identity verification, where human authenticity can never be assumed just because a user has the correct password or looks right on a webcam. Authenticity has to be continuously and cryptographically proven. And the organizations that adopt these automated API-driven authenticity checks, they will possess a massive operational superpower. The ability to guarantee trust at machine speed in an environment where literally anything can be synthesized.
It really is the defining competitive advantage of the next decade. But, as we map out the trajectory of this arms race, we are forced to confront a rather sobering reality. Well, today, our primary defense against synthetic media relies entirely on identifying microscopic digital flaws. We are hunting for the missing breaths, the perfect lighting mismatches, the subtle frame jitters. We are relying on the fact that the generative models still make physical mistakes.
Right.
But what happens to human trust when those models inevitably learn to intentionally replicate our biological imperfections? When the AI learns to simulate a perfectly timed breath, or to fake a vocal stutter, or to perfectly render the flawed lighting of a messy room, will the very biological flaws that currently prove we are human eventually become the ultimate disguise for synthetic media?